Thank you very much for the introduction and good morning to you all. Do I need to use a microphone or can you guys at the back hear me? Yes? So if my voice fades away, just let me know, right? I'm old, I'm 49 now. So just in case, right? Okay, so can you see the slides at the back? Yes? All right, so I have prepared few slides just to support my talk. So I believe visual things are much better than the vocal things. So what do you see at down there? There are a few logos. I think Dr. Ruan mentioned a few organizations that I am associated with. I'm just putting those in my first slide just to sort of respect them because I'm working with some of the organizations for the last 22 years and directly or indirectly these organizations and the colleagues that I'm working with in these organizations have actually supported me to whatever the things that I'm sharing with you is actually being supported by the intellectual knowledge that these organizations have. I'm not going to go in detail to describe the organizations, but we will directly get into the business today, which is sort of supporting you in terms of finding out the future for you. So it's a kind of a very difficult task. I hope you all agree. Predicting something about the future. The future is very uncertain, especially in the field of technology. Now, telecommunication is a subset of the vast technology field, and for that matter, engineering and other stuff. So, really predicting, in fact, I'm not going to predict the future for you. I'm just trying to guide you and give some of the tips that I would think that will help you in the long run to find your future by your own, right? I don't think that we can sort of decide or sort of take decisions on someone's future, how it is going to be, but rather we can support one to sort of guide to reach whatever the destination that person want to reach. So if you have any question, just raise your hand and ask, because I don't want this to be a very formal session. So try to be interactive. If you have any question, just stop me and ask. I have no intention to cover all the slides, right? The intention is actually to support you. If you have any question, any burning question that you want to get clarified based on the expertise that I have, we don't really have to follow the slides. But to start with, I will first start with what is really happening in the telecommunication industry. So this is the industry I've been working for the last 22 years, and this is an industry which is 170 years old, right? And the world telecommunication industry is 170 years old. The telecommunication in Sri Lanka is also 170 years old. You know that we were under British, and at that time when the rest of the world, especially the colonies and the areas where British were ruling, they implemented the basic telecommunication infrastructure. So the same thing happened to Sri Lanka when the Europe and all the other Commonwealth countries under British were implementing telecommunication infrastructure. They were actually implementing the same infrastructure here in Sri Lanka. But we all talk about digital economy, right? And if you really look at why telecommunication is important, is because of this, right? Now, the Sri Lankan government has a digital economy strategy 2030 or something like that. But basically, a digital economy can be reached based on the support of digital infrastructure, right? All the economic benefits, all the things need to be supported using a very robust digital infrastructure. And that will not just stand there. You need to have the digital laws and the policies, the frameworks, the guidelines, and that is why a government is needed, right? So, provided that those two things are there, you can actually realize the sort of vision of a digital economy. Now, if you just forget about the laws, the policies and all of that, down there you see telecom and IT infrastructure is actually the foundation of the digital economy, right? Basically the digital infrastructure. So that is why telecommunication is important, and telecommunication today is not very much like what we had 30 years ago, right? Telecommunication was a very, it was a very standalone industry when we started it 170 years ago, and when the personal computer, internet, software, IT, computer programming were commercialized in late 90s, things were drastically changed, right? So since then, we find that we are now becoming a subset of the larger ICT industry, right? So this is very important for you to understand, those who are thinking that the future job opportunities or the future higher education directions, that if one thinks that my future is going to be on telecommunication, I'm afraid there's nothing called telecommunication as such going forward. It will be a subset of the larger ICT industry, right? You will understand why. So that is one thing. Second, this digital infrastructure that I mentioned, we basically do two things, right? This is where you need to sort of broaden your mind. Rather than thinking telecommunication per se, you have to think about the larger industry of ICT. ICT stands for what? Information and communications technology. There are two things: information technology, communication technology. Usually telecommunication is for communication technology, and IT used to be something else, right? The computers, software, your colleagues, maybe you have people from the computer engineering department. So we usually categorize as IT and telecoms. Communication technology is telecoms, information technology is computers, programming, coding, all these IT guys. It's not the case now, right? So all are now interconnected. But when it comes to infrastructure, we basically do two things. We deal with bits, right? Digital economy is also about digital. Digital is mostly IP, Ethernet and packets, ones and zeros. So you have to transport your bits from point A to, let's say, point B. Usually these 2 points are two computers. It could be a data center, it could be a cluster of computers, server, client server, server, client data center, client, data center. But anyway, what goes between these two locations are the bits, right? So you have bits per second, which is the measurement that we use to find how fast can I send my bits from one location to the other. Then on the other side, you have your computers basically. You have to do two things: process your bits and store your bytes. You can store, of course, you are storing your bits, but we use the word called byte, right? So these are the two things that we do at very fundamental level. We talk about AI, cloud native, cyber security, AI ops, DevOps, and all the other things. But if you go drill down, and if you really see what this ICT industry is all about, especially on the viewpoint of telecommunication, telecom people are supposed to do these two things. So this is the fundamental thing, right? But fortunately or unfortunately, what's now happening is that this part is now going down. Going down in the sense it is more or less hidden now. Everybody, even in telecom space, everybody talks about artificial intelligence, machine learning, cyber security, cloud native, and all the things. If you take the ISO OSI stack, all the things that people and the industry talks about today is all about the application layer. I'm talking about physical, data link, network, and up to, let's say, layer 4. So we now talk more about things above layer 4, and things below layer 4 are now sort of hidden. Everybody expects networks to work. Everybody expects data centers to work. So it's kind of something that is given, right? But you still need engineers to do engineering to run this network and infrastructure. You need to architect. So you need to first strategize, architect, design, plan, implement, operate, maintain all this infrastructure. So engineers are still needed there, right? So that is number 2. Number 3 is the kind of business problem that we have. You will have Bachelor of Science in Electrical and Electronic Engineering, specialized in telecommunication, something like that. But once you get into the industry, either to a place like Sri Lanka Telecom or Dialog or Hutch or a vendor like Huawei, Cisco, Juniper, Nokia, Ericsson or someone, you will be given this problem. Now what is the problem? As I mentioned, before the commercialization of computers, the internet, IT and stuff, we had an industry which is voice dominant. Telecom companies like SLT, we were charging something like 400-500 rupees per minute for an IDD call. Let's say you want to call some of your relatives, let's say in UK, probably you can ask your parents or grandparents, they might have been charged something like 500 rupees per minute. So it was a very jolly good period for all the telecommunication operators in the world, not just in Sri Lanka. Because we were dominant, our business models were basically around selling voice. Because there was no voice over IP, there was no voice apps like today. We have WhatsApp, nobody takes internet, literally, very few people use a land phone to make an international call. My father does, because he doesn't know how to operate a mobile phone. Same for my mother. My father is 88, my mother is 80. So they still use the land phone to make a voice call to, let's say, to speak to my brother or something. But other than that, do any of you use a land phone to make an IDD call? No, you use WhatsApp, right? So that period ended in 1990s. When those things were commercialized, that's where the problem started. Now, to make a simple voice call, you need just 64 kilobits per second. If you convert it to voice over IP, at max you need 100 kilobits per second, but you can even work at 80, 90 kilobits per second. But the moment you move to the data dominant business, your traffic is now increasing, right? You need to build infrastructure to support that traffic. Now we have fiber to the home for example, currently we have over 700,000 fiber to the home connections. Those connections grow from 300 megabits per second to up to 1,000 megabits per second. And then we have broadband and all the other things. So traffic volume, everything increases, so you need to build the infrastructure. We annually spend something like 25 to 30 billion Sri Lankan rupees for infrastructure, right? We earn something just over 100 billion per annum, that's our revenue. Out of that, we spend 1/4 of that on the infrastructure, the capital investment. So cost is increasing. How about the revenue? Right? In some companies now have like the chief executive officer or chief financial officer. Now I have seen some companies now have chief revenue officer. Right? Nothing to do with this, but revenue is not increasing. Last year it was something like 104 billion. This year, more or less the same. Right? Revenue is not increasing. How about the number of customers? Right? This is not just in Sri Lanka. If you go to any market in the world, this is the same thing. Right? Customers are also not increasing. Okay? Not increasing, especially if you take the mobile space in Sri Lanka, you can go to TRCSL website and check the statistics. It is something like 130% mobile penetration. And it is going like 131, 32, 33, but it is more or less saturated. If you check for the last 5 years, it's like a flat thing. It's not increasing. Right? Now this creates decoupling of network traffic and operator revenue. Of course, you cannot plot all these things on the same graph because you have cost, you have traffic, you have revenue, you have number of customers, but this is just to understand the problem. This is increasing, this gap is increasing. This has been increasing since 1990 or late 1990s. Right? For the last 30 years, this gap is now increasing. Now the problem then and the problem now and the problem for, let's say, for the next 10-15 years going to be the same thing. Only thing that is going to change is that you will see the gap is widening. Right? How to close the gap is what is expected by you when you join the industry. Right? So you, of course, you will become engineers, but this is not an engineering problem. Of course, you can use your engineering knowledge to find a solution to this problem. Right? But this is not an engineering problem. This is a business problem. So it's very important, even if you become someone expert in telecommunication, you will be working for a business organization. Right? Sri Lanka Telecom Mobitel is a business organization. We are a service organization. We have like 500 engineers working with us. But still, we need to find solutions first to business problems, and then you can apply your engineering knowledge in some places. I will show. How do you bring the cost down? How do you increase the revenue? This is where you need to find, now, you know the problem. I hope you know to a certain extent what is the problem. Now you can decide what sort of expertise of me can be used to find solutions to this problem. For example, if you are an engineer with the expertise in automation, by the way, is a very generic term, but you can apply automation to multiple things. You can automate networks, you can automate customer service, you can automate certain operations, you can automate certain maintenance activities. How about virtualization? If you are an expert in virtualization, of course we have all the data centers now virtualized. How about virtualizing the network? I think Dr. Yuan mentioned something about virtualization. DevOps, which is entirely coming from the other side, I mean the IT side. But we still use DevOps in telecom. AI, artificial intelligence. So these expert areas can be used to bring the cost down. right? Any questions up to that point? Okay. Next, how about the revenue? It's not enough just bringing the cost down, right? You can do that, but that's not enough. You need to increase the revenue also. But how do you increase the revenue? What are we selling today? We sell voice, internet, television. Basically, that's it, right? Other than that, we sell some of the services to enterprises, like to banks, hosting services, cloud services, VPNs, cyber security solutions, etc. But most of our revenue comes from those three services, like internet, voice, and entertainment, which is television. To increase revenue, you have to be very flexible and agile in terms of your product design, product launch, and also the product life cycle management. Now, agility and flexibility comes from where? It is also come from the other side, I mean the IT side. IT people always talk about agility in software, flexibility in software. If you compare software and hardware, software is very much agile and flexible. You can change software things very easily compared to do a change on a breadboard. Of course you can change, but let's say you have a circuit board, some circuit design. Which one is easy? Change things on a hardware circuit board or on MATLAB software? To do it in MATLAB is very easy, right? So you need to bring the same principles to telecommunication. In all what we do, we need to be flexible and agile. Basically think on software angles, not like hardware, right? So you have to be able to sort of extract all the hardware capabilities to software, and that is exactly what SDN, NFV, and other technologies do. Then of course you can try to find a solution to this problem, right? By the way, how many of you take this recommended elective course called telecommunication softwareization? Is it active now? Not yet. Okay. Right. And very briefly, another slide just to show you what telecommunication today is all about. We have infrastructure, right? Basically the wires, optical fiber, data centers, ducts, poles, etc. Then on top of that we build networks like your routers, switches, optical equipment, servers, etc. On top of that you provide services. Now you have two things. Down there you have the digital infrastructure. It is infrastructure, but now we qualify it using the word digital. It is basically the two things that I mentioned, your network and the data center. And on top of that, you provide digital services. It's services, but we can use the word digital as a qualifier because most of the services that we consume today are digital in nature. So what are the characteristics of this? If you go down, you need high capex, like 25 billion per year to run that network or to expand that network. So your capital expenditure is increasing. Therefore, we call the bottom infrastructure asset heavy. You know what is an asset, right? It is asset heavy and capex heavy. The top is called asset light and capex light. For example, if you have a service, let's say something like Uber, right? Uber rides or Uber food. You really don't need infrastructure of your own. I don't know where Uber is run, but suppose PickMe is run on AWS, I guess, right? So AWS is not PickMe's infrastructure. If you have a software application which is at the top, you can rent or borrow infrastructure from somebody else, right? So that model is like that. Average revenue per user is kind of different. For example, what is the average revenue per user from telecoms in Sri Lanka? Any idea? For mobile, it is less than $2 US. For fixed, it is something like $8 US. In India, for mobile, it is less than $1 US. Right? Very difficult sort of survive in that type of market. Right. How about the competition? In Sri Lanka, if you take the digital infrastructure, you have SLT, Mobitel, Dialog, and Hutch. That's all. Only three. So you have to compete with three competitors. But digital services, how many? You have to compete with Ubers, you have to compete with Pygmies, and all the digital space you have to compete, right? So the competition is higher when you go top. How about the growth and innovation? Now all the higher layer topics that we discussed, AI, cloud native, cyber security, and all of that is more about the digital services. Right? So innovation is the rate of innovation at the top is high compared to the rate of innovation at the bottom. For example, like if you take the innovation of optical communication speeds, we talk about 400 gigabits per second, 500 gigabits per second, 1 terabits per second. It's growing, but not compared to the things that are there at the top. Right? And the talent. We have enough talent to take care of the bottom part. Right? How to configure an IP router, IP addresses, optical communication, even satellite, 5G. That knowledge is already there in this industry. And that is the hardware-centric knowledge we have acquired over the last 170 years. Now we cannot survive with that talent, right? To survive in the business, if you like or not, you have to move to the top part, right? It is competitive, it is of less ARPU, right? But you have to move there. The real problem that we have in the industry today, we don't have talent to run the top part of the business, right? So if you think that I want to become someone expert, or even without expertise, I want to be someone in telecommunication industry, going here is pretty easy. With your basic knowledge and all the things that you'll be getting from the faculty, going here is very easy. But provided that it has all these conditions. Going there needs, I would say, some effort. Right? I hope, or I don't think the faculty can make you someone fitting up there. Right? Certainly the faculty will make sure that you will fit here. Right? But if you really want to be in the top part, you have to do your part to make sure that you are going to be still relevant in this hyper-connected digital economy and this changing market conditions, right? And we are competing with, how much time do I have? We started a bit late, right? Another 15 minutes? Okay. So, we are competing with people like AWS, right? If you take satellite, if you take Internet of Things, machine learning, these are the things already AWS, Google, and other people already selling as services. And we are going to compete with these guys. And there is, I hope you cannot see that at the back, so we will skip this slide. Now this is what is happening over the years. And I have been in this industry for last 2 decades. So I have seen, by the way, SLT is now somewhere here. Right? I started my journey in 2003 when we had time division multiplexing, circuit switching type of technologies, and then we moved to IP and packet, basically IP and Ethernet, and then we in early 2000s we started softwareizing our networks, technologies like software-defined networking, network functions, virtualization, and cloud. We are halfway through, and we are moving to what you call as a telco cloud. Telco cloud is nothing different from what AWS infrastructure is. Right? So that is why I mentioned that telecommunication no longer is a standalone industry. We are a subset of the large ICT industry, right? So that is where we are moving. So we are moving away from hardware thinking. We are moving to software thinking. We need people who can softwareize networks, meaning that we need engineers with networking knowledge, but actually to program the network. Earlier what we did was we configured routers, we configured switches, we configured boxes. But now we need people who can abstract the hardware information to software and do kind of a software programming for the entire network. That is what we call software-defined network. So your thinking needs to be changed from hardware to software. You should actually be able to do coding. I will show you on the network. Same for data centers. Right? And we are leading to cloud native, and to AI native type of networks. Right? Don't worry about AI, because some people they say that AI will, because of AI you will lose your jobs. It will not happen, especially in telecommunication. Right? To drive this industry to that level, we need engineers who can actually go through that journey. And this is what softwareization is. It's a combination of software-defined networks, network functions, virtualization, and cloud. But going forward, telco softwareization, if you want to apply softwareization in telecommunication, it is going to be something more than just SDN, NFV, and cloud. It will have cloud native, it will have AI native, and few other things. I will be very brief on this slide. This is what happened to our industry. It started somewhere in 1876. Telecom companies used to do all the things. For example, we had a company, we still have AT&T in US, American Telegraph and Telecommunication Company. They used to manufacture their own switches, PSTN class 4, class 5 switches. And they dig the trenches, they erected the poles, manufacturing switches, connecting them, everything was done by AT&T. But then later came the vendors like the Cisco's, Huawei's, Juniper's, Nokia's, Infineras, etc. They slowly started doing the manufacturing of telecommunication equipment and systems. Right? So initially we were hardware centric, hardware switches, big boxes. But now it is very much software centric. But as of today, telecom companies like SLT Mobitel, we do very minimum R&D. Absolutely very minimum. Right? All the research and development is done by the vendors. So one choice for you is, if you want to be in telecoms, one choice probably would be, if you really want to apply your engineering knowledge in telecommunication, you can go to a place where real research and development on future telecommunication is really happening. Chances are that those things are not happening right now in telecom companies. Huawei does. Huawei has a lot of research labs. Cisco, Juniper, everybody has. And also open source communities like Linux Foundation, Cloud Native Foundation, they do have. But unfortunately not the operators. Very few operators like South Korea Telecom, NTT, and Deutsche Telekom in Germany, they have, right? And the focus there is not hardware. Your focus now, future innovation is all about software, cloud native, and AI native. It's telecommunication true, but it is happening on software entirely. Of course, there will be people who will be designing circuits for 5G devices, 5G radios, etc. There will be, right? Without hardware, you cannot talk about software. But most of the things, the innovation will happen around those areas. So these are some of the technology trends driving our business. And these are some of the things that the future telecommunication business would look like. We have 3 zeros: zero weight, zero touch, and zero trouble. Right? This is for the operation. We call it autonomous networks. Autonomous means that it's like an autonomous car. The network, the infrastructure, the digital infrastructure runs on its own and take care of all the things. But to design this network, we need you. Right? And also, human in the loop is very important. You cannot let an autonomous agent or an AI agent to run all of these things. You still need engineers to do certain interventions. And we have certain other things, for example, AI ops. Let's skip that for the moment because of the time. Same for this one. And by the time you join the industry, we have operators already at level 4 autonomy. Level 4 autonomy is that everything is done by a system except demand mapping, which needs human intervention. Right? By the time you join the industry, all the dimensions of network intelligence is automated. But to do automation, we need you. Once automated, you need to just sit and watch. Because if something is automated, like if you are riding on an autonomous car, are you going to do things on that car? No. Only thing is you design the car. Now the car is an autonomous car. You just sit and watch. Right? So that is one thing. And we are applying, for example, generative AI first in customer experience management. Slowly, maybe in 26, 27, we are taking it to operations. Like, for example, you can ask the network, how do you feel today? And it will say that I have certain blocks in these network areas. This is the condition. By this rate, if you don't expand this network segment, you will reach 75% of the traffic by end of the day. Something like that, right? So that is AI. And these things, all the things that I mentioned, these happen very fast, right? These things happen very fast. So it's up to us to whether we actually try to adopt these curves, right? And these are some of the fastest growing and faster declining jobs. I will just read out: big data specialists, fintech engineers, AI and machine learning specialists, software and application developers, security management specialists, data warehousing specialists. All at the top, right? Not the bottom. Bottom is something that we think that it is there. Infrastructure just run by its own, but it doesn't, right? You still need engineers to run the infrastructure. Fastest declining, I don't think we need to go. In number of million jobs, Those are the percentage growth, right? You still, the farmers, laborers, other agriculture workers, 35 million jobs are there. Why? Don't ever underestimate the farmers and the agriculture. If possible, try to support them. Without farmers and agriculture, there won't be any software engineers. There won't be any telecommunication engineers. They are the ones who actually supply food for us to survive. So they will have their jobs anyway. But third is software and application developers. Again at the top, right? So don't think telecommunication is about the wires, the connections, the routers and switches. Telecommunication is software and application. But forget about the application development. It's all about software. And this is a dark factory. I hope you have seen this. So this is how automation looks like. You really don't anyone to run this factory, but to set up the factory you need engineers are needed. Right? But once the factory is set up, you don't need people. Core skills. Now you will anyway be getting your Bachelor of Science in Electrical and Electronic Engineering, specialized in telecommunication or whatever. But when you go for a job interview, what are the things they want from you? Core skills in 2025, by the way, this is from, the source is from World Economic Forum Future of Job Survey 2024. I don't think they have 2025 yet. You can go and see for yourself. It's the top 5 skills. Analytical thinking, resilience, flexibility and agility, leadership and social influence, creative thinking, motivation and self-awareness. I don't think these can be taught at a faculty, right? So this is why you need to take part in sports, take part in these type of activities. Those who actually organize this, that is about the leadership skills, the teamwork, team building, your extracurricular activities like your singing, dancing, and all of that. That is what molds you as a complete human being. Of course, you have your Bachelor of BSc Engineering. That is there, right? That is very easy to get. But these qualities, it's not easy. You have to open things up. If those qualities, by the way, those qualities are there in everybody. You all have these qualities. Only thing is, it is now hidden. Whenever you get an opportunity, try to open yourself up and try to show your leadership skills, your analytical skills, your critical thinking skills, right? That is what is needed from the industry. Of course, we can train someone to do software engineering. It's very easy. We have training centers, we can send people abroad to do training. But if I am recruiting someone without these qualities, it's very difficult for us, right? So that is very important. And this comes, technological literacy comes at 6, AI and big data comes at 11, networking and cybersecurity comes at 17. So if you go to a job interview with a Bachelor of Science in Electrical and Electronic Engineering, can I take another 10 minutes? Is it okay? Right. They will not look at your technical knowledge, especially in the future, right? Because network and cybersecurity goes up to 17th level. The idea is that if you have those qualities, right, I can recruit you and train you with network and cybersecurity. But if you are very expert in cybersecurity, of course you will find a job somewhere where you need no people interaction, you work in isolation like a robot, of course, yes. But the modern work environment is not that. You just don't go and work in isolation. You have to work with people, you have to collaborate, you have to explain, you have to do marketing, all of that, right? So try to try to develop those skills as well. Now, what are the barriers that we have? The top barrier is skills gap and in the labor market. Remember the second slide I mentioned? The top is difficult, the bottom is easy. Getting to the top needs talent, and we don't have that talent in the industry. And that talent is very expensive. Companies are willing to pay you like 1 million, 2 million to a very good cloud native engineer. Right? And AI is not an option, but again, what is the barrier for AI adoption? It is a lack of skills to support adoption. You don't have people with enough AI skills. Right? That is why AI is important. Right, now we will get into what I found from your website yesterday night. You still have this sub-specialization. So, communication and information technology is definitely one. But you still have artificial intelligence and signal processing. I did not go into detail, but artificial intelligence, I don't know why it is not communication and artificial intelligence. So if there's any way that you can combine those two, that would be great. But practical possibilities of doing that, I don't know. And you have automation here. So if there's any way that we can combine, I would rather combine communication and IT with artificial intelligence and automation. That will exactly fit in to what the future that we are envisioning for telecommunication for the next 10-15 years. Right? Then you have this technical elective courses. I was really happy to see telecommunication network softwareization there, because that was something I worked with then Dr. Vijita, now he's a professor. So we actually worked on that, and I'm happy to see, but it's not there to take, right? You cannot take that yet, so probably in the future. So highlighted are the ones that if I am you, if you ask me what sort of electives that I go for, these are the ones. Artificial intelligence, machine learning, telecommunication network softwareization, artificial neural networks and deep learning, data communication, computer architecture, data structures and algorithms, and operating systems. Those are the, how many electives, by the way, you can take? Any number of electives or just 2, 3?
You can do any amount of electives, but only around 5 subjects will be added to the GPA.
Yeah, I don't care about the GPA, right? If you have the capacity, I suggest that you take them all, right? If possible. Now, if you are by operating system, anybody taking operating systems? No one. Now, all the things that I mentioned, all the telecommunication infrastructure software RISE is run on Linux. So if you don't know how Linux kernel is working, it's very difficult. Because we sometimes do kernel level programming for some of the optimization of networks, right? So the Penguin or the Linux operating system is very important. That is why operating systems are important. Then computer architecture, data communication, data structures and algorithms. Any of these things are familiar to you? Python, Go, Java, Ruby, yes? Then good. Because everything future telecommunication, no, even now telecommunication is run mostly on Linux, and all the programming is mostly done on either Python, C, you don't have Ruby here, Go there, Ruby, Go, Java type of program, right? So that is why those two things are important, but every other things that I highlighted are important. This is from the Linux Foundation talent report or something, but they say again last year, certifications rank higher than college or university degrees, about 23 to 16% when assessing technical skills. By the way, a degree is not to assess your technical skills. It's to assess your theoretical and fundamental knowledge of engineering. But if someone to assess your technical skills, the industry now uses certification, right? And going forward, I mean, we need to be very open and I have a Bachelor of Science in Engineering degree. But going forward, especially in the world market, they will not care whether you have a degree or not. No, right? If you have the skills, let's say you are given a Google data center with, let's say, 500 servers. You need to virtualize and run that infrastructure. If you have the skills to do that, they really don't care whether you have a degree or not. But to prove that you have that skills, you need to have some sort of certification. So the bonus for you guys is that you have the degree, and how about you top it up with certain certifications? Then you will be more attractive compared to someone just having certifications only, right? So that is why certifications are important. And there are multiple certifications. For example, Cisco. I did my CCNA back in 2001, right? And then did I CCNP and few others. So this is a very good certification if you are into networking. And today's CC whatever is more oriented to software design network or software defined networks, right? So good place to start is Cisco. Another place is Red Hat Linux. I don't know anybody is providing just Linux certifications. These are all distributions of Linux, Red Hat, SUSE and all of that. But Red Hat is good one. You have architecture level certifications and engineer level certifications. Right? You have Red Hat certified engineer. It is not given by a university, right? But this is a very recognized certification in the industry. So you have Bachelor of Science in Engineering and Red Hat Engineering. Try to combine both. Then 1 + 1 is like 5, not 1 + 1 is 2. I hope you get what I am telling you, right? It's a bit expensive, but if you have the courage, I hope you can do it. And the Linux Foundation has a career roadmap supporting, especially on the infrastructure and the security. Don't worry about the software development. Yeah, we are not very much into software development. Software development is from like computer science and computer programming stuff. But computer engineering and telecommunication engineering is more about systems and infrastructure. There are a lot of certifications. I will share these slides. Someone can remind me. I will share the PDF versions of these slides. So you have all the acronyms that you want to find. Try to do at least one of two, right? And then there are certain best practice certifications. These are skills certifications, specific skills. These are best practice certifications by this Excelos organization. This is basically IT software management, IT project management, IT infrastructure management. These are the kind of best practices that we use in the industry. And CIMA, for example, English certifications. If you think that you want to do advanced English certifications, go for it. That will improve your communication skills. And if you really at least try to do, if interested, you can try to do the first level certification of CIMA. I had one of my friends who actually completed CIMA by the time he graduated in 2001. And he got acquired, or rather he was hired by an Ireland company there. It's because the combination, 1 + 1 is not 2. You have Bachelor of Science in Engineering plus CIMA. So he ended up in Ireland, right? So these combinations are very important. So how do you combine them? You have the first part already there, which is your Bachelor of Science in Engineering. Whether it is going to be CIMA, Red Hat, Cisco, or something else, you can decide, right? So combination is very important. And this is something what I did, right? This is actually very much after passing out of the faculty. I did all these certifications. All the certifications that I mentioned earlier are vendor specific. It's either coming from Cisco, Red Hat, VMware, Dell or somebody. But these MEP certifications are vendor neutral. They just check your technological skills. Right? You don't have to remember how the Cisco CLI works, for example, or the bash commands on Linux. So I did all of that, and in fact I'm part of MEP now. I'm doing certain work with them. I'm designing some of the exams also, right? So these are some of the vendor neutral things. So you have a certification for SDN and FE if you want, right? And about your personal brand, there are two things. How you see yourself, that is when you go in front of the mirror in the morning, and how others see you, like how I see you. So there's an interchange. I mean, this place is your personal brand. You all have a personal brand. Try to use it, right? How to use it? Today's context, it's all about these tools. By the way, I don't use other than X and LinkedIn. You cannot find me in any of the platforms, right? So I'm not saying that you should get rid of Facebook or Instagram or something like that, but try to be productive in your social activities. So LinkedIn is a very good platform, very powerful platform. X is not so powerful as LinkedIn, but LinkedIn is definitely you need to have, and keep it up to date. And people go and check your LinkedIn profile to find, for example, I usually go to LinkedIn and find people for some of our projects and some of our project work. And try to go and find your social selling index. This is my index as of yesterday. So they rank me one of the top 1% in the industry. Right? I'm very good at building relationships, but I'm very bad at finding the right people. And I'm also not good at engage with insights, but I'm like midway good at establishing your personal brand. Right? So this is a free tool, right? On the LinkedIn. Just go and see where is your lacking. But LinkedIn uses your LinkedIn profile activities and how others interact with you and come out with these measures. So if you think that you are really not good at building relationships, try to improve that. Right? And the memberships. I'm a fellow of the top IET and BCS. I'm a senior member of IEEE. I'm a life member of SLAS, and I'm a member of all the other organizations. So I started my memberships when I was a student, as a student, and I continued that membership. That also gives you a lot of networking. We have events. When you go to events, you go and meet people in the industry. So you start building relationships. Now, internships, interviews today are mostly about relationships. Of course, if you have qualifications, you will get through. But relationships, connections are more powerful. So for example, if someone asks me, can you recommend someone for this particular project? If one of you have already worked with me in one of the projects, then I know that this guy is very good at, let's say, software-defined networks. So this is how people select, find talent in the industry. Last slide, undergraduate projects. So these are 3 projects that I did with few of your senior colleagues, and I think Professor Maheshi was the academic supervisor for the last project, but others, she's there somewhere. So all these projects became published papers, right? So you just one project is a must, two is good, but try to take the project to a paper, right? For example, all these three projects, the first one, implementing an intrusion detection system for a software-defined network using artificial intelligence. Second, performance analysis of hierarchical SDN controllers in a control arrangement in SDNs. Third one, performance comparison of ONOS and open daylight controllers in software-defined networks. So I happen to supervise all these three projects for few of your colleagues, and you can go and check where they are now. The second project, the people who did that project, I think two of them got selected to Dialog just because of the project. I did not recommend any of them. They just go and show that this is our final year project. The ability of them to do a software-defined network was the key concern of Dialog to recruit them. Right? So a final year project is very important. Not just don't do it for the sake of doing it. Select a good project. If you need my support, let me know. I think most of you have final year students now, it's done. But the others, if you really don't have a supervisor from the industry, if you have a project idea, if that matches with me, I'm ready to support. But I'm mostly on the stuff that I mentioned. SDN, NFV, cloud, cloud native AI, those are the projects that I would like to support. Okay, so that's it. As Dr. Rohan mentioned, my motto always is learn, share and explore. I always learn. Sharing is something that I did just now, and I always explore. Thank you very much. Sorry if I have taken more time, but there was no option, right? Thank you. If you have any questions, you can ask. Any questions?
Yeah, guys.
Do you have a lecture after this?
No, it's lunch break.
Lunch? And next lecture starts at?
It's 1 week.
Okay, so you have 40 minutes. I know how you eat, right? You don't need 40 minutes to eat. So we took just 5-10 minutes to eat. But anyway, you can ask if you have any questions. You can ask. If not, my email address is udunuara, my last name @gmail.com or IEEE.org. And few of you know my mobile number also, but if you have anything, you can always call me. But if I do not answer, I will get back to you. Right? Anything you want to ask, you can ask either in Sinhalese or English. No problem. Yes.
So let's say we have some fundamental knowledge in Excel and SDN, NFV, all of that. So how we get into a project? We don't have any idea of that area.
Yes.
Project idea. So how do we?
You just do some research. Now those projects that I just showed you, they started like you. When I am doing projects with students, I never go and do the project with them. I will just give you the kind of the four corners and the clues and the guardrails, and let them start from the scratch. It's better that you don't know. If you know, then you start from your knowledge to the next level. If you don't know anything, you have to do research for even to understand what is SDN. And some of them, by the way, started like that. I asked them to study and explain me what is SDN, right? What is NFV? What is cloud? What is AI? Right? So if you don't know, that is good. I mean, it's a gift. The problem with the society today is that people know things. If you don't know things, then only you learn. Right? So start learning, and then from the scratch you can start. It will take a little longer compared to other projects, but if you have the will and the courage, even I can support. Not just you, but any one of you who wants to do a project and you have an idea, just let me know and we will have a brainstorming and see how to materialize things. You will learn a lot from a project than from your core course. That is guaranteed. You spend like 3-4 months on a particular project full time, it's worth like a master's or a PhD for you. Okay.
Yeah, so with that, actually, I think this session is not just like, keep letting you know what's in the industry right now, but it's much more than that. So I hope that every one of you got a large insight than you expected. So, ladies and gentlemen, shall we have another round of applause, Mr. Udunuriye? And now to deliver the vote of thanks, I would like to invite Ms. Manuli Karunaratna, the Secretary of IEEE Industry Application Society.
Good afternoon, everyone. On behalf of the IEEE IAS student branch chapter of our university, I would like to sincerely thank Mr. Anuradha Udunuvara for taking his time out of his busy schedule to be here with us today. We truly appreciate you coming all the way to our faculty and sharing your insights on the field of communication and information technology. Your talk was very inspiring and helpful to all of us. Thank you very much. And we would also like to thank Dr. Ruwan Ranawira for his valuable time and his presence here today. And also we would like to thank Professor Dilantha Samaranayaka, Dean of our faculty, and also who is the Senior Treasurer of our society, for his support and guidance through these events. And a big thank you goes to KH Newsletter team for covering today's session in their photography. And I would also like to thank our fellow committee members for organizing today's session. And a big thank you goes to all of you for attending to today's session. Your presence made this event more meaningful. Finally, thank you once again, and we hope to see you all in our next sessions.
Thank you, Ms. Manuli. And now to present with the token of appreciation, let me invite the President of the IEEE Industry Application Society, Mr. Ravindu Marapana, and Ms. Udunur, can you please come on stage?